Okay, we'll do some other set of programs today. Okay, so that day we did this COBOL PGM basic sample display program. Okay, it is a very simple program. It does not have anything complex in it. So I'll just cut the content and I'll create one more program, PG1. So now today we'll discuss about something called variables. What are variables? So if you remember in the first class, we discussed about identification division, environment division, data division, and then procedure division, right? So data division is used whenever you use either files or you link two programs or you use some variables. So today we are going to use some variables. Division. Now, first of all, let me write. This is how a variable will look like. Now, what is a variable and why is it required? Okay, here leave 0, 1. I will tell you what this is. First of all, this is the name of the variable WSA. We generally write WS to denote any variable. WS means working storage. So you can write without WS also. You can write define any variable. That's fine. WSA is the name of the variable. Picture clause is a keyword here. X is data type. 10 is length, then value mainframes. Now, what is a variable? Why is it used? In a program, suppose you are reading one file and you are generating some output field. Now, the calculation or evaluation of the output field is long. Okay, you have few steps to do, like few calculations you have to perform to get to the output result. Now, after each round of calculation, the output, whatever comes, you need to put that output somewhere, right? And then carry that to the other part of the calculation, correct? Because suppose there are three calculations, after then only the final result comes. So after each round of calculation, the out you keep the output somewhere, then only you can use it in the next round of calculation, correct? That thing is called variable, which will always carry the values from one part of the program to another part of the program. So variables are some uh, properties or something you can say in COBOL programs which are used to carry values from one part of the program to another part of the program. Understood? Understood now?
Yes, yeah, it's unclear.
Hmm. Now, what is 0, 1 here? Okay. 0, 1 is called level number. What is level number? So, every variable, when you define any variable, you define it with some level numbers. So, how many level numbers do we have generally? From 0, 1 to 99, we have 99 level numbers in COBOL. We have 99 level numbers in COBOL. Now, where will we use 0, 1? Where will we use 0, 2? Where will we use 0, 3, 0, 4? Where will we use 99? This has some rules, okay? Now, in our case, this WSA is an independent variable. Like it does not come under any variable and no other variable is part of this. No other variable comes under this. This is a standalone variable which is independent also. Okay, which is independent variable. Now in this kind of cases, the level number can be either 0, 1 or 77. You can use either 0, 1 or 77 in case of independent variables. But sometimes we define variables this way. WSA, suppose WS name, and the name we will divide under in two parts. Suppose 02 WS first name. 02 WS first name picture clause. Suppose x of mm, sh- x of 10 and 02 WS last name picture clause x of 10. So I have taken a group variable. This is called group variable. I have taken a group variable under this. two sub-elementary variables are there. Now these are called sub-elementary, which are part of this group variable. This is the parent variable. Under this, we have two child variables. First one is first name, second one is second last name. In this kind of cases, most of the times we use 01. 77 is also used sometimes, but we use 01 mostly in case of group variables. And this child, if for this child variables, you cannot use 01. You can use anything between 0 to 299, except 77, 66, and you can use 49 and 88 also, but these two will also come in some separate cases. Now see, don't get confused. First, understand that there are 99 level numbers. For any variable declaration, you need level numbers. So there are 99 level numbers. If you have independent variables like this, okay, you can directly use either 01 or 77, both will work, no problem. If you have a group variable like this, then you can use 01 for the group variable, and from 02 to 99 you can use anything except 77 and 66. So 77 is used for independent variables, 66 is used for a concept called renames, and 49 and 88 are also used in sub-elementary variables, but those are different concepts you generally should not use. These will come in some specific concepts only. Got it? Any doubt till here?
No, it's not true.
So level number, then data name. This is called data name. WSA is the name of the data. Name of the data means the variable name. Pic is called picture clause. Picture clause is nothing but a keyword or a function in mainframe which will make this variable functionable. Then X. So there is something called data type which will come. What is data type? Now in this variable, what kind of data you can store? Whether you can store alphabetic data or numeric data or combination of alphabets and numeric. So if it is alphabetic, then you can define it with A. If it is alphabetic, you can define it with A. If it is numeric, you can define with 9. 9 means numeric. If it is X, it means alphanumeric. That means you can store alphabets, numeric, special characters, everything. So here I have defined it with X. The meaning of this is in this variable I can store alphanumeric data. It can be alphabets, numerics, mixture of alphabet and numeric, everything, anything I can store. But if I had defined it with A, I will be able to only store alphabets. I cannot store special characters or numerics. If I define it with 9, then I can only store numerics. I cannot store alphabets and special characters. Got it? So data type X, this one means data type. Now after that I have written within bracket 10. 10 means the length. How much maximum data it can store? How many length of data you can store? It can store maximum of 10 data. 10 digits. 10 characters or 10 digits. Value. What is the value of this variable? I have defined it as mainframe. Within single quotes I have written. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 characters I'm passing here. It is alphabet. It will be accepted under data type X. Length is 10. Maximum length here is 10. So it is okay. And I cannot pass more than this. I cannot pass 11 characters here directly while defining it. But I can pass less characters while defining it, no problem. So this is how I have defined a variable here. This is the description. Now here what I will do is I will display, okay, let the normal display be there. I will display one more line, display WSA. So now see, there is a difference between the displays this time. Yesterday we had this display hello world. So it displayed this as it is because it is there within quotes, single quotation or double quotation. So whenever you write anything within single or double quotes, it is printed as it is in spool. But here I have displayed WSA. It is coming in green color, right? Whenever you display a variable in output, you will get the value of the variable. In spool, you will not get WSA. You will get the value of it. Because if you want to get WSA, you have to write it within single quotes. But since I have displayed WSA, the value of WSA will be displayed here, mainframes. Then stop run is to stop the program. Let me have one more display. Value is colon space WSA. Got it? Any doubt in the program, let me know now only.
No, it's clear.
Clear, right? So
Yeah.
I have to compile the program first. So I'll go to the library where I have kept the compilation JCL. So I'll open that. This is my compilation JCL, okay? You don't need to worry about anything. You can directly use the JCL. You write your program name here and write your library name here. That's it. COBOL PG1 is my program name. jb.cobol.srclib1. Okay. This is my source library where I have kept the program. See, and this is my program name COBOL PG1. That's it. You don't need to change anything else. Submit it. Max is 12. I have done some mistake. I need to correct it. It should be either 0 or 4. But since it is coming 12, that means I have done something wrong. So I will go to spool. Start as semicolon st. It will directly take me to spool. Okay. Now, this is the job question mark. I will have to directly go to this COBOL part because there are two steps in compilation. One is uh, compilation JSL. One is the normal compilation. Another one is link edit. So first of all, I'll check with the compilation. These are generic tabs which are generated always. This is the COBOL part. Let's check here. S. Go to the bottom. MF8. MF8 is used to go to the bottom of a page. Here, if you go come to the bottom now, the error will be written. The messages will be written. See here, if you see, there are total two messages in this from this code. Informational messages 0, warning message 1, error message 1, severe message 0. Warning you can ignore, but the error message you have to fix. Now, what is the error message? See, just on top of this, you will get all these kind of messages. Hyphen W, hyphen E. Hyphen W means warning message. Hyphen E means error message. If there is severe message, hyphen S will be there. So hyphen E you need to check. A data item was found in the data division before a section header was encountered. Okay, working storage section. I forgot to write. The meaning of this is I have declared this variable directly under data division. Under data division, you have to write working storage section. So under data division, we have few sections. Working storage section, linkage section, and file section. All the variables should be defined under working storage section. Whenever you define any variable, you have to mandatorily write data division and working storage section. Whenever you have a file, you have to write data division and file section. Whenever you are linking two programs, you have to write data division and linkage section. Three sections. Okay. For variables, working storage section. For programs, linkage section. For files, file section. So I forgot to write this. I will save it. Now go to this compilation JCL again, submit it. You don't need to change, it is already changed. Max is it 12 again. Let's check. Go to the COBOL part, MF8. So from this COBOL part, IGY CRCL compilation part, there is nothing. Everything is fine. See, only one message that is also warning. No error, no severe, so it is fine. Go to the link edit part. S. Here see, there is no space left in the directory for ddname ccell mod. Okay, now what is ccell mod? This actually is coming because I don't have any space left for this file, left in this load library. I have to create a new one. That is what it's talking about. These are normal things only, don't worry. These are not coming from the code. So I will create a new one. So let me create a new one. I will create loadly one. Okay, it is done. So I'll give loadly one. So now I will try to compile this. I did not check what was the output. Or it is still running. Okay, the load library is open, I guess. Or what? maxc4. So compilation is successful, right? Now go to execution. jab.cobol.sourcelib. So here cob run. So just write the program name COBOL pg1 and here give the load library name. New load library. I have created one, so it should be one. There is no file, you can ignore. Okay, this is our execution JCL. Submit. Then go to spool. Spool is already open here. I will go. The last one. Question mark. Go to sysout because we have some displays. So now check with the program and try to match. First display was hello world. It should come directly as it is. So hello world is the first line. Second display was WSA. So I displayed the variable. So the value of WSA should come. The output is mainframes. Then third one is value is colon space WSA. See, within single quotes I have kept a space also. So it will come as it is. This part will come as it is. Values is colon space. It will come as it is. After single quotes I have written WSA. So here the value of WSA will come. That is mainframes. So see. Did you understand the display pattern?
Yes, yeah.
Clear? Any doubt till here? Anything?
So in this we are giving values, right? So
Hmm.
the mainframe, right? Without value we can pass
Yeah,
the
yeah.
input.
The next example we are going to do that.
Okay, okay. Yeah, no doubt for me.
Okay. So if you don't give any value, suppose you keep it this way, just define a variable and don't give any value. Then what will happen is in output you will not get anything. So let me compile pg2. Let me execute it. pg2. Then if you check the output, so we'll see. Now try to match. The first displays hello world. It came directly as it is. Correct? So hello world. Second display is display WSA. So the value of WSA should come. WSA you defined but did not provide any value. That is why the default value will be taken. Default value for alphanumeric data type is spaces. If you have a data variable whose data type is X, but you have not provided any value, so default value will be spaces. If you have a variable whose data type is alphabetic A, default value will be spaces. Same for alphabetic alphanumeric. But if you have numeric 9, but you have not defined any value, then the default value will be 9. Sorry, default value will be 0. So that is why here it is spaces because for the second one we don't have any value. For third one, display value is colon space WSA. So value is colon space till here it is same. And after this there is nothing because it does not have any value. Now same program you do for 9. For alphabetic if you do it will work the same way. Now if you do for 9, 9 is what? Numeric. Now I will compile. I have changed the program. I will compile it. I'll submit it. Now, if you check the output, right, was the compilation correct? Mm, Okay, got it. I will have to show you in this way. Display. Okay, before that, let me show you one more thing, then I'll come to this one. So, okay, I'll come to the numeric part next. First of all, I have defined a variable like this with x, okay, but I have not assigned any value. So, next thing is we can assign a value from procedure division also. Like we have to move A, B, sorry, move what was the value? Mainframes, right? Move mainframes to WSA. Move mainframes to WSA. So the meaning of this is when you define this variable, it did not have any value. Now you are passing some value. Then if you display this, the output will be similar to the previous one. Okay. If you compile this, so see output is same. Hello world mainframes value is mainframes. Okay. This is how you can pass some values also. Now, what is the scenario when we generally pass values when we directly define it here? It is totally dependent on your project requirement and how you handle the project. Now, there is no specific rule that in this case you have to define. If you want to have a variable which should have a hard-coded value and you will use that variable at many places in the program, you can directly define a value here. Suppose you want to have a date of 0001 hyphen 01 hyphen 01 at many places. Then you can define a variable and have the value hard-coded here as 0001 hyphen 01 hyphen 01. But if you want to have a variable and in this variable you want to move different values at different parts of the program and you want to use that time you can just define the variable and move values whenever it is needed in the program. Okay. Now there is one thing here that you have defined a variable but there is no value. Now inside procedure division you are moving something. So in this case sometimes this move statement might fail. This move statement might fail because this variable may have some junk values in it. You have built a house, but no one is staying there. Now, after 2 years, you have planned to stay in that building. So what will you have to do before that? You have to clean the building, right? Because you are not no one is staying in that building. It might have become dirty. There might be snakes, there might be insects in the building, so you need to clean it up. Then only you'll be able to stay there. Similarly, you have defined a variable, but you have not assigned any value. So there is a chance that in these 10 digits, in these 10 places, some junk characters have come and are placed automatically. So in that case, this move statement will fail. That is why before passing this move statement or before passing any value with move statement, we have to always initialize. Initialize WSA. So initialize means to clean the variable. So if there is any junk character here, it will be removed. Or in place of initialize, you can write move spaces to WSA. Now why move spaces? Because it is alphanumeric variable, you have to move spaces. You cannot move zeros. You can move zeros, but that will be meaningless anyway again. You can move spaces. So initialize will always clean it up, clean the variable up. Now if you have a variable like this, value mainframes here, that one you should not initialize because you have already a value here, and if you initialize this mainframe value will also will be gone. If it already has some value, you should not initialize. If it does not have any value, then only before moving something you can initialize. Got it? Clear or not? Any doubt? Initialize you understood?
Kind of okay.
Yeah, can you explain it one more time so that I can be
Okay.
understand better?
Yeah.
You have a variable, but there is no value defined to it. So there is a chance that some junk characters will come and it will be placed here. That is why we write a statement called initialize to clean the variable so that we can move something inside it. If you don't write initialize, sometimes this move statement will work. Sometimes it will fail because there will be some unwanted or junk characters into this. There may be. It is not necessary that always it will be. Since you have just defined this variable but you have not assigned any value, this all these 10 places are empty. There is a chance that junk characters or junk values or unwanted characters are placed in this variable. So this move statement might fail because you are trying to move mainframes into this variable but it already has some junk value. This might fail. That is why before moving anything we should always initialize. Initialize means to clean the variable. Okay? We have to always initialize. Now, you should not initialize a variable which already has some value. You should always initialize something which does not have any value.
So this can be used when whenever we initialize a variable, or means whenever we use a variable, or
Whenever you are using any variable and you are moving something inside the variable, before moving, you have to initialize.
okay, okay.
You
So
are
if we
using any.
use the move
Yeah.
command, we should use initialize, right?
Yes, yes, exactly. Before move command, we have to always initialize a variable. And also, you will get to know these things slowly, slowly. Sometimes what we do in the program is, suppose we read a file. The file has 1,000 records. Now we read all the records one by one. We read, then write the record in output in another variable. So every time before writing, we have to initialize so that the next iterations don't fail. After moving the first value to one variable, suppose I'm reading the file, it has 1,000 records. First record I'm reading and I'm moving to WSA. Then from WSA, I'm writing in the table. Second record I'm reading from file, I'm writing in WSA. From here, I'm writing in table. So before moving every record in WSA, we have to initialize WSA so that the next movement from file to this variable is smooth. Otherwise, if we don't initialize WSA after and before every move, sometimes this move statement from file to this variable will fail. So when there are iterations, when you are reading a table end to end from beginning to top to bottom, and you are writing the data in some files or in some variables, and from variable you are writing files. Before writing the data in files or variables, you have to always initialize so that it works properly. Because otherwise, initialization gives huge issues, and initialization issue is very difficult to find also in the program. Sometimes we don't understand only why this initialization issue is coming. It's very difficult to understand sometimes. Got it? Any doubt still? Let me know. Tell me if you have any doubt.
It's okay, it's okay. Yeah.
Okay. Now let me have a variable with 9 and I'll see what value comes. So I'll move 0 1 2 3 4. Okay, I'll take 9 of 5 length only, huh? I'll push a value 1 2 3 4 5. Now whenever it's a numeric variable and you want to pass something, you don't have to write it within single quotes. You can simply write it without single quotes. Okay. This program I'll try to compile. So I'll submit this compilation JCL. Then I'll submit this execution JCL. So you can see the first display was hello world. So hello world. Second display was WSA. So WSA was 1, 2, 3, 4, 5. And third display's value is WSA 1, 2, 3, 4, 5. This is how it will be displayed. Got
So
it?
I have one dot. Like in
Hmm.
when you declared like instead of 9, uh, previously you have used X, right?
Hmm.
To denote alphanumeric. So in that case, we didn't use initialize and move, and we got a value of empty spaces. So in this case, if we not initialize and move, what will be the output we get? Like there it was spaces. Here if we use numeric, what will we getting?
You will get zeros. If you don't move,
Hmm.
suppose,
Okay, okay,
if you don't move, you'll get zeros. Submitted. The zeros. 5 zeros. So
okay,
the the reason behind this is its default value for numeric variable is 0. Default value for alphanumeric value is space. Now if it is x of 5, it will be 5 spaces, but spaces you can't detect directly, right? It looks
yeah,
normal,
yeah,
like
yeah.
it looks blank, but there will be 5 spaces. For alphabetic also 5 spaces. For numeric, if it is 5, 5 spaces. If it is 10, 10 spaces. 10, sorry, 10 zeros. So hello world, then 5 zeros, then value is 5 zeros.